This presentation will illustrate the process of building and training a machine learning model on the Titanic dataset, with a goal to predict whether the passenger survived or not based on the features we have at disposal. The actual survival outcome is provided in the dataset. Therefore, we will apply supervised learning using the XGBoost tree-based algorithm. A precondition is the dataset is uploaded successfully in the dataset section. Click Add on the Quest Overview page, add the name of the quest, and save it. Drag and drop the Import Data activity and select it. Choose the dataset from the drop-down menu, then again click Save and run the quest. The output port of the activity now displays the data and its statistics. Some general principles for machine learning algorithms are that most of them cannot work with missing values, so we will need to either remove them or impute values to them. And most of them cannot process string values, so we will need to transform the string features into numerical. It is important to be familiar with the data to be able to decide what you need to do to build a good prediction model. Determine which features are relevant to the specific use case and ignore the ones that are not important. After exploring the data in our example, we have estimated that features like the ticket class, sex, and age are influencing the survival rate. However, the columns containing ticket, name, and passenger ID are redundant information with high cardinality content, and we most probably don't want to include them in the training. In summary, before training the model, we need to prepare the data accordingly. At first glance, we can notice there are a lot of missing values in some of the columns. So let's start by handling the missing values. We will not exclude any column to handle all of them. The method we can apply, for example, is replace with mean. Then we will specify the label using the edit metadata activity. We select survived and specify the machine learning type as label. We will use the select columns activity to exclude the redundant columns. Passenger ID, name, and ticket. We'll again apply edit metadata to convert the string features to categorical. Then we will convert these to numeric using the one-hot encoder activity. We usually want to split the data into training and testing part before the training. This will allow us to score and evaluate the trained model on unseen data. To do that, we will use the split data activity with a ratio of 70% for the training and the remaining 30% for the testing portion of the data. Then we will apply train model activity and connect the training data as input. In Apply Algorithm, we select XGBoost and configure the objective hyperparameter to binary logistic classification. We will connect the algorithm as a second input into the train model activity. We will score and evaluate the model with the test data and the trained model as inputs. Then we'll save and run the quest. In the output of the score model activity, we see a new column displaying the probability rate of the predicted class. The evaluation output displays the evaluation metrics. These are different for different types of algorithms or different hyperparameter configurations. In our example, we notice precision and recall have pretty high values, and the ROC curve looks fine. This implies the model is performing good. In the confusion matrix, we see the count of true and false negatives and true and false positives. The matrix provides a good insight about how well your model does. In the end, it's entirely up to the user to decide if the trained model is satisfying or he wants to modify and retrain it. But let's say a solid indicator for a low performance model can be, for example, accuracy and precision below 60%. The higher their value, the better the performance. We can train multiple models in parallel flows within one quest and compare up to 4 similar ones. Then, as soon as we're happy with the evaluation results, we want to continue further to the production part of the quest to eventually deploy the model and obtain predictions. This part will be presented in the next video.